Alright, hello people, how y'all doing? Today we are gonna do parametric equations. Pretty simple concept to be honest. I wouldn't say it's too complicated of a concept to comprehend. There's a couple things that you should practice. We'll go into them though. So what is a parametric equation? So here it says recall that a function is a relationship that passes the vertical line test. So a function that is y in terms of x or x in terms of f or whatever the function is, which is usually some variable in terms of another variable, right? Hello. Okay, I guess this doesn't want to go away. It's some variable in terms of another variable, and that is the function usually. And when you graph the function, whether we have a parabola, and then when you do the vertical line test, the graph doesn't cross a vertical line twice. As soon as it crosses the vertical line twice, it's not really a function anymore. So if I have a function that goes like this crosses twice. And as you can see, that wouldn't be a function, a normal function at least. And so, what is a parametric equation? A parametric equation is that your y doesn't depend on x and your x doesn't depend on y. They both depend on a third variable, which is t in this case, and it's just a variable. Don't think too much into it. So what is parametric equations useful for? If you're good at physics, we'll go through a simple concept right now. So in physics, if I have a ball here, and I want to throw the ball up and across, let's say like a football, and it goes, here. And on our x coordinates, you see the ball on the x traveled in a straight, constant speed. Didn't change speed, unless neglecting air. It didn't change speed. But when you look at the y, it went up and it slowed down. You see here, the slope is 0. That means if you derive your distance, you would get velocity to be 0 up there. And so it slows down, it becomes 0, and then it speeds back up. And you see these two things are completely independent of each other. But what they do depend on is time. They both pass through time. And also our function, the other thing about regular functions is that when you graph them, they don't tell you direction. You see, this tells you like you can go this way or that way. It doesn't specify a direction. And that is also an issue because you can't determine where it was at a certain time. Like if I give you a time, you can't tell me where the ball is. So that is an issue. The other way is you can't tell me the direction it was traveling, and that's the second issue. And so that's why we introduce parametric equations. And so instead of us having y in terms of x, we'll have x equals we'll have x in terms of t and y in terms of t. And so x will have its own function, which determines the straight line that it travels in. And my y will have its own function that will explain this parabola it travels in. All right? And so you see here, there's an example. We have x sine t, and this is the same thing as saying y equals sine x. It's just in terms of x and t. And you see now this is my x, just like if this was your y, this would be your y. And this is my t, right? And as you can see, sine, you have here the 1 to -1. And that is your range. That the same as if you have this y and y in terms of x, and we have y in terms of t squared is this function. And so here you have your t and you have your y. And you might wonder, well, why is this not curving the other way? And the reason being is, like I was saying, t does have its limits. And yes, it is a time, but don't think about it that time can be negative, because here t is just a variable, it's not necessarily time. A good way to think about it up here would be time, but it's not necessarily always time, it's just a variable. So y here has a restriction that it starts at 0 and it goes all the way up and it goes in this direction, right? Well, actually here it doesn't even specify which direction it goes in, so I'm not gonna assume that, but that's the way, because it could go, from 400 down to 0 if it's slowing down. You could go backwards, which is not likely, but that's a possibility. And so if you combine them together, as you can see now, when you combine them, you have your y in terms of x, and so this is your y and this is your x like normally, except the only difference is that you see the range of x is the same range here. And my range in -1 is here. Okay, and so also, if you pay attention, your maximums on your x are the same. So you see my maximum here is 1, and there's 3 of them, and my minimum There's 3 points and there's 3 of them. Also, the highest point I got in the y was 400. You guys can't see that. And you can see here, this is also 400, right? And so the same thing range, and then from y, it starts at 0. And as you can see here, it doesn't pass through 0. It just starts at 0, right? Or it stops at 0. And so it takes the same characteristics. It's just like your girl when she does a plastic surgery. She looks different, but the characteristics are the same. So now we're going to go down here and we're going to match some equations. And these might look a little bit scary, whereas they're actually pretty simple. The easiest one to start with here is your cos and your sine, right? And all these your coses and your sines. You have another sine here, and you have another sine here. And because this will eliminate this one, and it will eliminate this one, right? And so that makes your life easier. Now you have 4 more to go. Now what is the difference? You see here, let's see. We can start here and we can match a couple things. So we can say cos, the range for x here, cos in terms of the range or the domain of cos is from 1 to -1. That is our cos. Now if we multiply cos by 3, what does that give us? So let's choose a point that is kind of contradicting for sine and cosine. They're opposites of each other. So the point I'm going to say is here, I'm going to say, hello? Okay, whatever. I'm going to say t equals 0. So I'm going to say t equals 0. And I'm going to say cos at 0 equals 1, right? And I'll do the same thing here. T equals 0. And cos, sorry, here would be sine at 0 equals 0. And so my y, my y here would equal 0, because 0 times 2 is 0. And my x equals 3. And so we can look, where is x 3 and y 0? Here, my x is negative, and then at 3, my y is nowhere to be found. Here, when my y is 0, my x is not 3. Okay. Let's see. Here, when my x is 3, my y is sky shooting. My x is 3 doesn't even exist here. When my y is 0, my x is 1, so it doesn't even match. Here we have 1. Doesn't match, but you see this one here actually matches pretty well. This is right here is 3, and when my x equals 3, let me write that better. When my x equals 3, my y equals 0, right? And as you can see here, this is the same thing here. If we say when x is 0, my y equals 2. And now how can I find this? I could say here, let me find t when x is 0. So I could say my x is 0 equals 3 cos t, right? And then I could do 3, take 3 the other side, will be 0 equals cos t. And now you can inverse, you can, what do you call it? Inverse your cos and then do 0. So when I can do cos inverse of 0, and I could find my t. You can find your t, then you can plug it in for your y up here, and you can find your y and confirm this method. And then you'll see your point is the same here. And so your y should equal 2. And so this confirms that this is our f. Right? Now this is the first process I took the long way so I can explain really what you can do. But this is not necessarily the only way you can do it. You can do it a lot faster. And so here, look at this. Cos, sine. Sine domain is between 1 and -1. Your cos is between -1 and 1. Right? And so this is between 1, 1, and that's -1, and that's -1. So my x here is -1, x, and 1. Right? And my y is the same. And so this matches that. Okay? Now the other thing you could look at in terms of here, so here we have the y is t squared minus 1, t squared minus 1. So we can ignore that because that is supposed to look the same. And you can see actually, since we have sine here, and we have sine t here, but this is 2t, what you could look at is what looks the same, and it's periodical on the y. And you see on the y, goes up, down. And this is 1, and that is our second one. But what's the difference? This one is more compact than this one, I'd say. It's more frequent. And so what is more frequent? Our sine t, this looks more of a sine t. This looks more of a sine 2t because it's more frequent. 2 times your t. So it's 2 times as many times, right? And so you could easily say this is your d. You could easily say that this is your c, right? Now when it comes here, right? When it comes to this equation, how do you find out which one is which? And it's pretty easy. Here you have y. If I isolate for t, I will get the square root of y. Well, not square, right? And so my t can be any positive or negative number, and that's fine. But you see here, if I do the same thing for x, I isolate, right? What will happen here is I'm looking at, you can't square root a negative number. And so when is x a negative? When is the root under here is a negative number? So we can say x equals x plus 1 equals 0, and then I can take x equals negative 1. And so when x is negative 1, I get 0. And so anything, if x is lower than negative 1, then I get a negative number. And so I can say the domain for this is that x has to be bigger than negative 1. Equals is fine, bigger or equal to negative 1. And you can say this one actually goes past x at negative 1. And so that's what we have here. This is negative 1 and it stops here. So that makes sense for our a. Right? Now what is left here is we have our t minus 1 and t cubed. And you can confirm this for b because your y can be either positive or negative. Your x can be either positive or negative. And the other thing here is you can say, when your y is 0, your x is negative 1. And you can sub that in. So you can say y equals t3. And we can say when y is 0, t cubed. And when I cube this, when I do, of 0 equals t. And that's just 0 equals t, right? And so when my y is 0, what is my x? So I'm going to take this t and sub it into my x. So 0 equals t minus 1. Well, I did it the other way. X equals 0. I subbed it in. Minus 1. And you can see x equals negative 1. And that is the same thing up here. Right? My y is 0. My x is negative 1. Now going to the next subject. Let's sketch the curve of parametric equation of this. How do you sketch it? Just like we used to sketch curves from, of y in terms of x, and we would make a table of values and we would sub them in, and then we look how it looks. You do the same thing, but here you have 2 variables, so you'll have to do it twice. And so you'll do t, and you'll do x, and you have your y. And if I can make a straight line, I can make straighter lines across, I feel. But anyways, so our t, you can start from any number you want, but the best way is to go from negative 2, 1, 0, 1, 2, because this gives you a great idea of what it will look like. And so you would sub it into here. So negative 2 times 2, negative 4, negative 1 times 2, negative 2, 0 times 2, 0, 1 times 2 is 2, and 4. And then what's my y here? Negative 2 times 5 is 10. Well, negative 10. And then negative 2 times, negative 1 times 5 is negative 5. And then we can do 0 times 5 is 0. And then you can do 1 times 5, which is 5. And then 2 times 5 is 10. And so now you basically plot these 2 points. And so we can look at negative 4. So you can say 1, 2, 3, 4. And negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And if I go halfway, 1, 2, 3, 4, 5. That's my negative 5. I go back twice. That's my other point. And then I have 0 and 0. And I have 2 and 5. And I also have my 4. And that's what it looks like. That's a great graph. And this, you can say we'll stop here and we'll stop here, because our range for t that we use is this, and it goes this way, right? But that's not necessarily, depends what parameters you put. But here, yeah, our t is not limited, it goes to infinity and negative infinity. All right, so now how do you solve? Now let's get some more practice converting from parametric equation to Cartesian equations. How do you convert from parametric equation to a Cartesian equation? And it's very simple, extremely simple. All you have to do, isolate for t and sub t in. And so here, let's isolate for t. Cos equals 4, x equals 4 cos t, x divided by 4 equals cos, and what I can say is cos inverse of x over 4 equals t. And now what I'm going to say is y equals 7 sine, I'm going to sub it in, of x over 4. And that's my Cartesian equation. And so I'll do the same thing here. This will just equal cos inverse of x equals t. Okay, and then you can sub that in, and you'll get your y equals cos cubed cos inverse of x. Your other way that you could do this, which you see here, you'll have to do some simplification here. The other way you could do this is, since this is technically cos t to the 3, and your x is already solved, so what you could do is you could just say y equals x cubed. And that is your Cartesian equation. Capish? These include astronomy, bizarre application, calculus. We now know about parametric curves, so how do we do them with calculus? Nice question. Okay, so if you want to find the derivative of a parametric equation, what you'll have to do is you'll do your dy over dt, so your y in terms of your y in terms of t's derivative divided by your x in terms of t's derivative, and that's about it. And then if you want to get your second derivative, what you'll do is your x in terms of t stays the same, the derivative, but your dy over dx will have to be derived again. Okay? And as long as your dx over dt does not equal 0. Alright, so let's do it here. We have x equals 2 and sine, find dy over dx. And this one you have to memorize. This is not given, but this one is given. That's why you get the check mark. And so what we'll do here is we've got to find first our dy over our dt, which equals, so we have sine 2t. And if I want to get the derivative of sine 2t, so what I could do is I could just say, right, and I can divide it, I can derive it using chain rule. And so what the chain rule says is bring down to sine t, that stays the same, times the derivative, which is cos t. I can't remember if this was negative cos, the derivative of sine, is it negative cos? I can't remember exactly, I'll have to confirm that, but if you guys know, please confirm that. I don't have the sheet on me right now, but that's my derivative number 1. My derivative number 2, what I'll do is I just have my t squared, and so when I derive t squared is just 2t, right? Nothing too spicy. And so now what I gotta do is I just gotta divide them together. So my dy over dt, so if I can say here, my dy over dx equals 2 sine t cos t all over my 2t. And that is my dy over dx of the derivative of my Cartesian equation. And now if I can go to the next step here, what do we have? We have if x equals this and y equals this, find it at this point. This one actually gives us a point. So we could do it simple, just like we did before. I'll start here, dy over dt equals So I have a t plus 1. I gotta derive it. So what will happen is this is the same as saying a t plus 1, right? And I can bring it down. And minus 1, which will give me a negative 1 over 2. And then multiply it by the derivative of the inside. The derivative of 8t is just 8. And the derivative of 1 is just 0. So it's 8 plus 0. And so now we'll leave this as is for now. We'll simplify it in a bit. And my second one is right. And when I wanna, the derivative of my 1 is 0. The derivative of my e to the 3 is 3t squared. And now what I gotta do is I gotta put them one over the other. Right? And so what this will equal 8 times a half is 4. And so this will simplify to 4 8t plus 1, then negative 1/2, all over my 3t squared. And you can simplify this even more, but for now I'll leave it as is. And it's saying find the derivative of this exact point. Now how can I find the derivative? How can I find the derivative of that exact point? What you can do is you can take one point, either this or you can take this, and you can sub it in. So either you sub in the 3 into the y, and you solve for t, or you sub in 2 and solve for t. This one looks easier to solve for t, so I'll just use that one instead. So what I'll do is I'll say x equals t3 plus 1, and I'll make x equal 2 equals t3 plus 1, and then take this to the other side. So what I'll get is 2 minus 1, which is 1, equals t cubed. And now when I square root it, what I'll get is t equals plus minus 1. So now the question is it plus or is it minus 1? What you can do is, since we know at 2 our y is 3, you can sub your 1 here. So if I say my y equals the root of a t plus 1, if I sub in my 1, I should get 3, right? So a 1, you can also put in your negative 1 and see which one ends you up with this answer. And so I'll just use my 1 because it's a little bit more obvious. So I'll say y equals 8 times 1 is 8, plus 1 is 9. The root of 9 is 3. So my answer is 1, positive 1. And now they're saying, well, find the derivative of that point. So you just sub it in. And so what I'll get is 4, 9, negative 1 over 2, all over 3 at 1 squared. And this what this will equal to. Negative 1/2 is 1 over 3. Okay. Negative 1/2 is 1 over 3. So because what this will look like is you'll have 1 over the root 9. And root 9 is 1 over 3. And so 4 times 1 over 3 is just 4 over 3 times my denominator, which is 1 over 3. Right? And so what this will give you is 4 over 9. So far, so good. That is my answer for this equation. Okay, so here it's saying if x equals t squared minus 4 and y equals ln of this, we are finding this at that. What t value will be? Will we be evaluating the derivative at? So like we said, you would sub it in. And so what we'll say is, we'll say up here, x equals t squared minus 4. And then when x equals 0, what is my t? Right? And so that would be plus minus 2. Right? Now, which one is it? So what we could do is we can sub it into here and see which one is it, plus or minus. So y equals ln t, and let's sub in 2. Let's see what that gives us with. But you see, just off right now, this will not give us a negative number, and our y is negative. And so that won't work. So what we can do is we can just flip this to a negative instead. And see if that works. So y equals ln of 1 plus 3 times negative 2. And so ln of 1 is 0. And that will give us negative 6. And so our answer is negative 2. So t equals negative 2. Right? And so now it's saying we are finding, now you got to find it. So you do the same thing we've been doing. You get your dy over dt, and then you derive. The derivative of ln t plus 3 is just 1 over t plus 3 times the derivative of the inside, but the inside is 0, or actually the inside is 1, because your derivative of t is just 1, your derivative of 3 is 0, 1 plus 0 is 1, times whatever this is, stays the same, plus my derivative of this, derivative of 3t is 3. I did not mess that up. Yeah, that should be right. And so now I also have my dx over dt. I'm a little bit rusty with my derivatives. So t squared minus 4. Your 4 goes to 0 when you derive it. My t becomes 2t. And so now we got to put them one over the other. So we have t plus 3 the power of negative 1 plus 3 all over 2t. I got to sub in because I want to at this exact point. Right? And so what this will equal to is negative 2 plus 3 right? And what this will equal to negative 2 plus 3 is 1. 1 over 1 is 1. 1 plus 3 is 4. 4 over negative 4. Negative 1 is your answer. All right. Now the question is, how do you get your second derivative? This is a given equation, so it's not too shabby. So we'll do something here. I don't know why I'm rewriting that. I still need my dy and dx. So let's get my dy and dx. So my dy dt equals t5. So I'm just gonna derive this right away. So your 6 goes to 0, and your t5 just becomes 5t4, and my dx over dt, e to the t, when you derive e to the t, it stays the same. And when I derive this, it's just plus 2. Okay? And so now what I'll have is I'll have my dy over dx equals my top derivative over my bottom derivative. All right, and so sorry I stopped for a second. I got a call coming in. But my top derivative of y over my bottom derivative of x, which is e t plus 2. And so now if I go back to the equation, what the equation says, the derivative of dy over dx over dx over dt, that is my second derivative. So if I want to find this, so first it says find dy over dx, that is my dy over dx. And now if I want to find my d2y over dx2, which is my second derivative, what it will be, my x plus my dx will be the denominator. The derivative of this will be the numerator. So now I got to derive this one more time. So let's derive this. What we'll have is 5t to the 4 times et plus 2 to the negative 1. And now what you got to use here is you got to use chain rule. If I remember it, no, sorry, you use product rule, and then you also use chain rule. If I remember it correctly, because we're multiplying two different equations. And so here's what we'll do. Let's use chain rule. So, sorry, let's use like product rule, and then we'll use chain rule. So, the product rule will tell you the derivative of 5t to the 4 will be 4 times 5, which is 20. And then it will be 20 t to the 3. Right? And then your second stays the same. all this plus the first stays the same times the derivative of the second. The derivative of the second, the negative comes down, right? The inside stays the same, minus, and multiply it by the derivative of the inside, which is just e to the t. And so if I simplify this real quick, there you go. So that's my first one. Plus my second one, this whole thing will become negative 5t to the 4 times e t plus 2 to the negative 2 times e to the t. Right? And so our equation says it's the second derivative of this over that. So what we can do is if I want to get my d2y over my dx2, this whole thing I'll just have to divide by my, what do you call it? By my x, dx over dt. And if you simplify this, I mean, you probably could simplify this, but I don't think you will have to. For example, this will just be out here, and we'll just minus this. And once that happens, this is also e to the t plus 2, e to the t plus 2. This is the squared. These two we can probably multiply them together or add them up. So there's a couple things you could do, but I will leave it like this for now. I'm not going to simplify. Okay. So if you curve a C if a curve C is described by the parametric equation this, A has to be within the parameters of alpha and beta, where f derivative g derivative continuous on A and B, and C transverse exactly once as t increases, then length of C is this. And so to find the arc length, what it's saying is, as long as your derivative is continuous on A and B, and your C is transverse once, exactly once, as t increases, then you're good to go. And you'd basically sub into this equation. And so I don't think I need to go through this. Find the circumference of a unit circle. And so what you'll do here is basically just sub in here, and you take the bounds, and that's about it. So you see here, they already give you the bounds. And you just got to get your dx over dt for this one and square it. You want to get your derivative of this one and you square it, and you add them up and put them in a root, and then take your integral, and that will give you the length. Only set up the integral. Yeah. So that's one thing. The second thing for this one, find the circumference of a unit circle defined by x. So the circumference of a unit circle is from 0 to 2 pi, right? And then you can integrate, and you can basically do this. You want to get your derivative, This equation is given, so you don't have to memorize it. And that is it for your lecture 1 of parametric equations.